Welcome to the linear relations part of our revision. Here we're looking at 2 points and we've got to work out which x is which x. So x1 is the x from the first point, x2 is the x from the second point. So we've got 5 and negative 1. y1 is the y from the first point, y2 is the y from the second point. So we've got 8 and 2. Just going to write them straight into their places in that formula. So we're still going to have all of our brackets, but we're going to have the 5 plus negative 1 on 2, comma, 8 plus 2 on 2, and our brackets. And let's just simplify that down. 5 minus 1 is 4, so we've got 4 over 2, and 8 plus 2 is 10, 10 over 2. So we end up with 4 divided by 2 is 2, 10 divided by 2 is 5. Next one down, using the same points, we are going to calculate the gradient. So using those same numbers, subbing them into the other places. y2 was our 2, y1 was our 8. So we end up with 2 minus 8 at the top of our fraction. At the bottom, x2 was negative 1, x1 was 5. So we end up with negative 1 minus 5 at the bottom. Now, 2 minus 8 is minus 6. And minus 1 minus 5 is minus 6. Minus 6 divided by minus 6 is 1. And that is our answer. Jumping down to our distance formula, same thing. We've got the same points, the same parts, putting them all into this other equation. We'll have d equals the square root of all of this stuff. So a really big, long square root sign for us. And then we're going to sub in our numbers again. You'll notice the numbers are getting subbed in the same way they were with our gradient formula. We've got x2 minus x1, which was our minus 1 minus 5, and then we're going to square that section and add it to our y2 minus y1, which was 2 minus 8, and then we're going to square that section as well.
There we are.
Alrighty, let's just simplify those bits underneath. Minus 1 minus 5 is minus 6, so we're going to be looking at squaring minus 6, and 2 minus 8 is also minus 6, so again we're going to be looking at squaring minus 6. We should all know that minus 6 times minus 6 gives us a positive 36, so we end up with the square root of 36 plus 36, which is 72. So our square root of 72, let's chuck into a calculator, because I don't really feel like doing that on my own without that. We end up with 8.49 to 2 decimal places. Next one, something we've done lots of times, completing tables using an equation. We are just looking where the x is and subbing the number in. So for our first one, we're going to have minus 2 in there. So y equals 4 times minus 2, which we know is going to be minus 8 minus 2, which is minus 10. So let's throw him into the table, and then we're going to look at our next number. Minus 10 in there, and our next number in the table of values is our minus 1. So we are going to put him into the exact same equation and do it all over again. Here we go, and we've got y equals 4 times minus 1 minus 2. I'm sure we all know that 4 times minus 1 gives us minus 4, so we'll have minus 4 minus 2, which is of course minus 6. Throw that into the table and find our next number. Again, we're going to be putting it into the exact same equation. Our next number in the table is, of course, 0. Let's throw 0 in there, and we've got y equals 4 times 0 minus 2. 4 times 0 is 0. 0 minus 2 is minus 2. Chuck them into the table and look at our next number and see what we've got. Next number from the table looks like 1. So let's put him into our equation. We've got y equals 4 times 1 minus 2. 4 times 1 is 4. 4 minus 2 is, of course, 2. Chuck him into the table, and the last number for our table is 2. So we end up with y equals 4 times 2 minus 2. 4 times 2 is, of course, 8. 8 minus 2 is 6. 6 jumps into our table, and our next question is where we're up to. Now we need to plot these values into this thing here. So let's have a look. Our minus 2 across, minus 10 down. We can go the minus 2 across, can't make it 10 down. Minus 1 across, minus 6 down. It's there, but not quite on our table. 0 across, minus 2 down. We can definitely put him into our thing. 1 across, 2 up. Put a dot in there. 2 across and 6 up. We can fit him on the grid pretty easy. Connect the dots, make the line, And of course the line continues for eternity, so we do have arrows on either end. Jump down to our next question, and we are looking at where the two lines intersect. It's quite literally where they hit each other. And if we look directly below, we have the x value of 2. If we look directly to the left, we have the number between 2 and 4, which is 3. So our point is 2, 3. Two lines that are parallel will have the same gradient. The gradient is that number in front of the x. We've got 4 and 4. 4 equals 4. So yes, they are definitely parallel.